Now in this lesson, I will introduce you to the concept of similar triangles, and I will also show you some methods to prove that triangles are similar. So we call this lesson similar triangles. Now the meaning of similar. I have a picture here of a lion. Now if I increase the sides, I will get this picture. So what's happened now? I have the same picture, but I enlarge or I increased the sides. So all their sides have been increased in the same ratio, which means if I write down 1 unit for this side, 2 units for that side, I have increased the sides in this ratio 1:2, which just means that this picture, the sides are twice as long as that side. Right, so if one object, in this case we have a picture, can become another using resizing or enlargement, the objects are similar. Right. Now triangles are similar too when we enlarge them. So we have two triangles in front of us here. And I have this one here, A, B, C. I enlarge the sides and I have this picture now. Right, or this triangle rather. And what do you notice? That their corresponding angles are equal. Angle A exactly the same as angle P. B and Q, they are equal. C and R, they are equal. Even if I flip the triangle around. What happened here? I flipped triangle PQR around, right? And still the same. P is equal to A. Q is equal to 55 and R is equal to 40 degrees. So if we can prove that all the angles of one triangle are exactly the same as the corresponding angles of another triangle, then they are similar. So similar triangles are different in size, as you can see, a smaller one and a bigger one. But if all three angles in one triangle are equal to all three corresponding, now the meaning of corresponding, matching angles in another, we say the two triangles are similar. So that's the meaning of similar. All three angles of the one equal to the corresponding angles of another, even if the size are different. So if the size are different, we say they are similar. Now how do we prove that two triangles are similar? Now we are going to prove here that triangle ABC is similar. So that is the symbol for similar, right? To triangle DCE. Now the layout is the same as congruency, exactly the same. So you must actually prove that angle exists. 3 elements you must prove. Now this one here, the letters must be in the correct order. I'll explain to you once we get there. So you start by saying that triangle ABC and DCE. Then you write in all the information about ABC below, and in the secondly you will write down all the information of DCE. You will not mix it up by writing DCE's information over here. First ABC's information. And you start by saying angle A is equal to angle D because it is given to you, right? You can see the size of angle A is 38, of D is 38, so it's given. Then we have B is equal to E. That's also given. Now the third one is not given, but we can figure it out because this one is marked with a little box, and we know that when two lines intersect like that, the vertically opposite angles are equal. With the result, actually angle ACB, alright, is equal to DCE. And it's not given, but it's vertically opposite angles. Now you can say, therefore, triangle ABC is similar to DEC, AAA. Now, why didn't I write it in that form there? The reason for that, letters must be in correct order when you conclude that two triangles are similar. What's the meaning of that? First of all, if you now write down ABC, A, B, and C, similar. So, because A is equal to D, right? A is equal to D, you can see there, you write D first, right? Because B is equal to E, that will follow now. And lastly, C is equal to C, right? Because you can see ACB is equal to ECD. This is the correct order, right? A equal to D, B equal to E, and C is equal to C. If you had to write it in that order, it would have been wrong, because that will mean D is A is equal to D, that is still right. Then B is equal to C, which is wrong, right? Okay, so next, we can also use side in proportion to show that two triangles are similar. So they say here, two triangles are also similar if all the corresponding sides this time have the same ratio. When you enlarge them, the proportion must be the same. Right, so what do they mean by that? Now the relationship between the lengths of sides MN and PQ is in ratio 3:6, which means, let me just write it down, 3:6. The length of MN is 3 units, the length of PQ 6 units. So we enlarged it from 3 to 6, and that is the meaning of the ratio. Now if you simplify it, it's even easier to see what's happening here. 3 into 3 once, into 6 twice. 1:2, that is the ratio in its simplest form. So this will actually read that PQ is twice the length of MN. Look, MN is written first, then PQ. So PQ is twice the length of MN. Right. Now, you can't just prove one side, right? All the corresponding sides must have the same ratio before we can say they are similar. So how do we prove that? Now we are going to use this 1/2 method, right? Like a fraction. So we will write the two correspondings like this, one at the top and one at the bottom. So we start always, very important rule, always start with the highest side. So it's MN, right? So MN is corresponding to, I'll just write it down, MN, right, is corresponding to. Now MN is opposite X, so the side opposite X will be the corresponding side, so that will be PQ. So MN and PQ, They are two matching sides. Right, so I have it over here. Mn over PQ. Next step, you're writing there lengths. Mn is 3 and PQ is 6. You simplify it 3 once, 3 twice. So we start always with the longest side. Now you go to the middle side. The middle side is 2. 2 is ON, alright? 2 ON over. Now ON is opposite the angle marked Y. So opposite the angle marked Y is 4 units, which means it is RQ. Right, RQ. So that will be our next one. ON over RQ. Then you write in the values. ON is 2, RQ is 4. Simplify it and it's 1 over 2. Lastly, you go to the shortest side, which is now MO. And MO, as you can see, is opposite Z. And opposite Z is PR. Right, so we have now MO. Right, MO is this one, opposite the Z, and opposite the Z, PR. Or RP, doesn't matter the way you write it. Then we simplify it, but it's already in its simplest form. So now you can see that all three lengths have the same ratio, and for that reason you can say that all the corresponding sides are in proportion. So MNO similar to PQR. Again, MNO. The letters must be in the correct order. Similar. Now you can see MN and PQ, they are the corresponding sides. So you write PQ first. PQ. Because MN and PQ, they are the two corresponding sides. The next one will be ON and RQ. You can see here, NO is the same as ON, and we have our R here because that is the last one there. So NO and we have RQ. They in the correct order and they are corresponding. And lastly, we take the first and the last. MO over here is equal or is corresponding to PR. So that is the correct order. PQR. So sides in proportion is the reason. Okay. Remember, we will start with the worksheet. You cannot mix these two approaches. Or your proof is about angles, or your proof is about sides. So all three elements must be about sides, or all three elements must be about angles. So we are going to prove now that triangle MNO is similar to PQR. The equal angles, they are marked the same. Some with one line, some with 3 lines, some with 2 lines. For you to really see the corresponding sides. Where do we start? We start with the highest one. In this case, it is 4. So we will write ON there, over, and we look for the highest side here, and the highest side must be over one line here, because 4 units is opposite M. So opposite P is 12 units, and I write it like that, and simplify, it is 1 over 3, and it's given to us. Next, OM, that is our second highest or the middle value. OM is 3 and QP. Now, OM is opposite the two lines, and opposite two lines we have QP. And the values 3/9. Simplify it and it's 1/3. Also given. Lastly, the lowest. The lowest will be MN, which is opposite 3 lines. And opposite 3 lines we get PR. You see there? So it's MN over PR. What is the value of MN? 2 units. What is the value of PR? 6 units. Simplify and it's given. So we have 3 corresponding sides. Right. 3 matching sides. The ratio all the same, 1/3. This sides is 3 times the length of that sides. Right, that's the meaning of it. 3 times the length of that side. So that is our ratio, 1/3. Next, therefore, MNO is similar. Now the correct order, we just check if that is the correct order. MN, there, MN over there, corresponding to PR. Right, PR, that is right. And Q must be the last one there. The next one, NO, where's NO there? And PRQ, yes, although the order is not the same. And lastly, MO, and MO here, and PQ. So this order is 100%. Right. Number 2. ABC is, or triangle ABC is similar to triangle TEF. The corresponding angles are marked X, Y, and Z. Right there, they are marked, which means this angle is equal to that angle, that one is equal to that one, and that is equal to that. Find the ratio of the corresponding angles. And number 2, use the ratio to find the lengths of GE. You must find the length of this side. And EF over here. Okay, let's start. Step 1, write down your corresponding sides, starting by the highest one, or the highest lengths. Right, so you can see in this one, AC is the highest, and AC is opposite X. And opposite X, you'll get GF. So that will be your first step. So it's AC over GF. The length of AC is 6, of GF is 8. Simplify and you get 3/4, and the ratio is 3/4. Now you must find the value or the length of GE and the length of EF. Right. Now I just want to show you something. We have this in grade 8. You were taught how to increase in a ratio and how to decrease in a ratio. If you still remember, if you have a ratio and you decrease, then you multiply it by 3/4, which means your numerator is less than the denominator. But if you must increase in a ratio, then you will multiply it by 4/3. So in the second instance, the numerator is more than the denominator. If you decrease, numerator is less than the denominator. Okay, so see what we did here actually. 6 increased actually to 8. You see there? Right? So I'll just give you an example. 6 increased in the ratio 3:4. Therefore, to get 8, we had to multiply 6 times 4/3. Because this side can't be less than that side. Right, so we increased 6 in the ratio 3:4 to 8. But when we multiply, the numerator must be more than the denominator to get that 8. Now that is what we are going to do, because 4.5, this side is longer than BC maybe, or BA, and that side must be longer also. It can't be less than the sides of this triangle, because this triangle is bigger. Okay, so we start. Our first one. We have that first one, that is our ratio. Now the second one, so we take the middle values. Right, so we have 6 already. The middle value is BC, 4.5. Right, BC over, and you go to that side. BC is opposite Y, so opposite Y you get EF. That's why we have BC corresponding to EF. So all you need to do now to get EF is to take 4.5 and multiply it with 4/3. Right now, if you do it on your calculator, 4.5 times 4 divide by 3, and your answer will be 6. So EF is equal to 6 units. Right, and that should be right. 4.5 increased, not decreased, increased, and that side is 6. We go to the last one, the lowest, and the lowest number is AB. So it's opposite Z, and opposite Z we have GE. So it's AB over GE. Right? AB corresponding with GE. So we find what is the value of AB? 3, and we multiply that with 4/3, and our ratio increased, and the answer is equal to 4. And that is the way you find the lengths of GE and EF. We have the ratio, but in this example it increased, therefore we turn that around. Okay. Number 3. In the accompanying figure, CD is parallel to BE. That is the symbol for parallel. You must now prove that triangle ACD, this is the big triangle here, is similar to triangle ABE, this triangle. So prove that the big triangle is similar to the small triangle. Now we can't use our sides. Why not? Because there's no clue to tell us that any of the sides are equal or corresponding or whatever. So we can use angles, because when we have parallel lines we have equal angles. Corresponding angles are equal and alternate angles are equal. Right, so we look for a pair of corresponding or a pair of alternate angles. Now you see this two on the same side of the parallel line, on the same side of the parallel line to the transversal. What do we call that? Angles? Yes, they are corresponding angles. Then we have another pair, right, from the parallel line to the transversal, from the parallel line to the transversal, and over there. So we have already 2 angles in the big triangle and 2 in the smaller triangle. Let's look for the third one. Yes, it's A. A belongs to the big triangle and to the smaller triangle. So we have 3 angles of ACD is similar to 3 angles of, actually the angles are equal. For that reason, the triangles will be similar. Right, angle D is equal to angle E, angle C is equal to EBA, and angle A is equal to angle A. And that is the way we write it out. We have 3 angles. And we start, angle G is equal to, we can't call this E, so we call it AEB, corresponding angles. And remember, because CD is parallel to BE. Next one, angle C, yeah, is equal to EBA, also corresponding angles, because CD parallel to PE, to BE. And lastly, angle A in the one triangle is equal to angle A in the bigger triangle. So they are common. And now we can write down. Therefore, triangle ACD, right? ACD. The orders must be right. Similar to angle A is equal to angle A. So you write A first, right? Angle C, yeah, is equal to B, right? And lastly, there must be the E. And angle D, where's angle D? There, is equal to that E. And we have the correct order, A, B, E. So that was also okay. Right. Let's just get rid of this. Okay, erase all the ink. Right. Next one. In the figure above, actually, this must be below, right? Not above, below. AB is parallel to DE. Prove triangle ABC is similar to CDE. Again, nothing we can say about the sides. Lines are parallel, so angles will be equal. So we will go for A again. Right. And we start. Where do we start? Here. Angle A and angle E, do they form a pair? Yes, they are from the parallel line to the transversal. Then on the opposite side, from the parallel line to the transversal, what do we call them? Alternate interior angles. Right, do we have another pair? Yes. Parallel line to the transversal, we make that 2 lines. Parallel line to the transversal, another pair of alternate interior angles. And the third one. Okay, the third one, and we have it. 2 lines intersect, so 2 angles, they are equal, vertically opposite. And you can start. Angle A is equal to angle E, alternate interior angles, because AB parallel to DE. Angle B equal to angle D, again alternate interior angles, AB parallel to DE. And lastly, ACB is equal to DCE. Why? Vertically opposite angles. Now you get to your conclusion. Therefore, triangle ABC similar to triangle, and we see if this is correct. A and E, yes. B and D, yes. And the last one is C and C. C and C, reason A, angle, angle, angle. Quite easy. Next one. Use side in proportion to prove that AOB, this triangle, is similar to triangle COD. AB is parallel to CD. So you're not going to make use of the angles now, but of the sides. But it's better to just mark the equal angles, and it's so much easier to see the corresponding sides or the matching sides. So I will mark the equal angles first before I start to prove that the sides are in proportion. Right. Two lines are parallel, which mean this angle and that angle must be equal. Alternate angles. But you're not going to write this down because they don't ask you to prove that. It's just for yourself, so that you can see which sides are in proportion. Right. So that one is also equal to this one. Why? Because it's alternate interior angles. And lastly, this one and, okay, make it a cross there. Make it a line there, two lines. And make that two lines. Right. So you start. Highest. Look for the highest first. Okay, and what is our first one? It will be AB. And AB is over opposite this two lines. So opposite this two lines is CD. You have it. And the value is 12 over 8 and 3 over 2. And the reason given. Middle value. What is the middle value? Right. BO, this one here, over, and you can see it's over the right mark there. So over this mark it is 6. So it's BO over CO. And the values, BO is 9, CO is 6. Simplify it and you get 3 over 2, and it's given to you. The lowest or the shortest sides. What is the shortest sides in this triangle? This one here, AO. And AO is opposite that one, and opposite that one is OG. AO over OD. AO and OD is matching sides. What is the value of AO? 7.5, of OD 5, and in the simplest form it's 3 over 2. Right. So for that reason we can say that triangle OBA similar to OCD, sides in proportion. Let's see if this is correct, because look at that one is COD, OCD. Now you see I had to change this around in order for them to really match. So I had to turn it because it doesn't work like that. But anyway, at the end it worked. OB, yeah, OB and OC. Right, BA, yeah, and CD. Perfect. And the last one, OA, this one here, OA and OD. So now and then you'll have to change the first one also around in order for the two to match. Okay. Now I have an explanation here for people who don't understand how to get to this one here. 7.5 divided by 5. That will give us 15 over 2 times, and you turn that around, 1 over 5. That is when you don't do it with a calculator. Right. And 1 times 15 is 15. 2 times 5 is 10. And you simplify it and you get 3 over 2. But I'm sure you still remember how to do your fractions. Okay. And then we get to the last one. You must prove that these triangles are similar. First of all, you must find, and then after you prove that they are similar, you find the ratio of the corresponding sides, and you use the ratio to find the lengths of sides marked X and Y. So you're going to find that side. But let's first prove that the triangles are similar. So you can't yet prove with the sides because you don't have all the sides. But I'm sure you can prove by means of angles. Angle, angle, angle. Let's see, because we have parallel lines. And once you have parallel lines, you have equal angles. Right, so let's see which angles are equal. We know already that there's 2 because they are vertically opposite angles. Then we have this line, transversal, that parallel line. So again we have a pair of alternate interior angles. Then lastly, another pair. Okay, we mark that 2, and angle 2 is alternate with, yes, angle E. Okay, we write down this. Angle A equal to angle G, alternate interior angles. AB is parallel to GE. Next one, angle B over here is equal to angle E, alternate interior angles, and AB parallel to GE. And then lastly, our 2, ACB is equal to DCE, vertically opposite angles, and triangle ABC similar to GEC, AAA. A and D, yes. B and E, yes. And C and C. Next, find the ratio of the corresponding sides. Go for the highest. Here we have 3 and 4 and an unknown. There we have 6 and 5.4 and an unknown. So in the first triangle, it will be 4. In the second triangle, the highest one is 6. So you can take 4 over 6 or 6 over 4. So in our example, we started with a bigger one. All right. So it's CE, and CE is opposite G, or this one line here. And opposite this one line, we have 4. So 6 over 4. And the ratio 3 over 2. We simplify it. Right, so it's 3 over 2. Next, now we have the ratio. We have that part. Use the ratio to find the lengths of sides marked X and Y. Let's see, X or GE. You see the second highest one here, GE. And DE is opposite this angle here. And opposite that angle there is AB. And AB is actually the unknown one. So we have 5.4 and Y, they are matching sides. 5.4 and y, they are matching sides. But now you must listen carefully, because y can't be more than this side. You can see it's smaller. So we're going to decrease in the ratio 3:2. Right. And for that reason, we have 5.4 over 1 times 2 over 3. And if you do it on your calculator, 5.4 times 2 divided by 3. And your answer will be 3.6. So this one is 3.6. And you can see it is shorter than this one. And that is correct. So you decreased in the ratio, or you decreased in the ratio 2:3. Or 3. Yeah. Then next one. Y. Okay, we have y. Now we must find x. X is over here. Right. So CD is opposite these two lines, and opposite the two lines is 3 centimeters. So we write it in. It's CD over AC. CD over AC. Because CD and AC, they are the matching sides. Okay, so we have it here. CD over AC. And in this case, it's x over 3. So we are going to increase or decrease? 3 must increase, because CD is longer than AC. Right. And for that reason, we increase, and it's 3 over 1 times 3 over 2. And your answer is equal to 4.5 centimeters. So this one is 4.5 centimeters. And this is our last problem. So if you didn't fully understand, please watch this video again, especially the sides. Right, I know that can be quite confusing at times, especially this number 6, where you must decrease and you must increase. So watch the video again, and also please subscribe and like my channel, and you will actually receive more lessons in future, even more worksheets. Thank you so much.